Hello all, we are from Pinellas Academy of Management and Technology, B Chemical. Our project guide is Professor Yogesh Lange. My teammates are Sujit Katkar, Tejas Zadav, and it's me, Abhijit Tarale. Our topic is study production of vinyl chloride and the attempt to upgrade the process. Our first objective will be to study the production of vinyl chloride monomer, and our second objective will be to decrease the coke production in the process. Now the introduction. VCM is a main product for the production of PVC, and PVC has a large usage in our day-to-day life. Now our goal is to design the environmentally friendly, safe, economical, profitable VCM production plant. Now let us quickly go through the material safety data sheet. The vapor density of EDC is shown here. EDC, VCM, and HCl is shown here. Now there is no liquid density because all the products we are going to use will be in the only gaseous form. Now LEL percentage is a lower explosion limit percentage, and UEL is a upper explosive limit percentage, and TLV is a threshold limit value. It is shown here. Now, our process is divided into two stages. First is production of ethylene dichloride from ethylene, and second is production of vinyl chloride from the ethylene dichloride. Now, here are the two processes. Here are the two reactions which will happen in the process. First, in the first process, the ethylene gets react with hydrogen and oxygen to form ethylene dichloride plus water with the help of catalyst UCl2. And another reaction is ethylene dichloride is decomposed, or you can say cracked, into vinyl chloride plus HCl. This is the outline of our process. First, the ethylene, HCl, and oxygen is sent to the oxychlorination unit, and from where the EDC form, and this EDC, raw EDC, crude EDC, is sent to the EDC purification unit, and after the purification, the low boil impurities and high boil impurities get removed out, and this purified EDC is sent to the cracking unit. And from this cracking unit, our main product, which is VCM, get formed. But this VCM is in a raw state, so we need to further purification of VCM. So we have settled here a VCM purification unit. Um, Now let us go through the material balance. We have done the material balance. We have also done a survey of market survey, and take a approximation of 360 metric ton per day of VCM on the as a basis. So for 360 metric ton per day of VCM, we need 80.58 metric ton per day of ethylene, and 210.09 metric ton per day of HCl, 46.04 metric ton per day of oxygen, and EDC formed in the oxychlorination process is 751.71 metric ton per day, but for the requirement of EDC for 360 metric ton per day is 1036.58 metric ton per day. So remaining 258.08 metric ton per day is imported from the other countries. Now here is the oxychlorination process, from where the uh, hydrogen chloride, oxygen, and ethylene is sent to the fluidized bed reactor, from where uh, where the from the top side the EDC gets formed, and here the catalyst filter is used for the filtration of catalyst and reuse it into the reactor. Now it is sent to the EDC purification unit through quench column to remove out the impurities uh, like water and unreacted EDC. So this is our EDC purification or EDC distillation unit. So this EDC, crude EDC, is sent to the heads column, from where the unreacted EDC or water molecules get removed out, and then it is sent to the high boil column, from where the low boiling impurities get removed out, and then it is sent to the vacuum column, from where the high boiling impurities get removed out. The low boiling impurities are acetylene, benzene, chloroprene, whereas the high boiling impurities are 1,1 EDC, 1,1 dichloroethane, 1,1 dichloroethylene, etc. And these low boiling impurities and high boiling impurities are sent to the incineration unit. Now this is purified EDC is sent to the cracking unit. Now, before sending EDC to the cracking unit, it is preheated for the less production of coke, and then it is sent to the cracking furnace. This is a thermal cracker which we use at 460 degrees Celsius, and here only the our main product, which is VCM, get formed, and then the from the bottom we get the VCM, and it is sent to the VCM distillation unit for purification through a quench column, from which the unreacted EDC or other waste gases get removed out. Now here is our VCM distillation unit. Here we have used a three column of for the VCM purification. The first column, from the first column we separate out the HCl, which is a byproduct formed in the cracking process, which we have seen in the previous slide. Then from the bottom, the HCl removed VCM is sent to the VCM column, from which the other impurities like byproduct impurities I have said, like 1,1-dichloroethane, etc., comes with the VCM, gets separated out, and then it is sent to the HCl stripper, from where the water molecules and the HCl traces can be removed out, and we get the VCM. The percentage of purification of VCM here is above 98%. Now these are the impurities: acetylene, benzene, chloropene, 1,1-dichloroethane, 1,13-dibutadiene, and 1,1-dichloroethylene. Let us go shift to our second objective, which is a decrease the coke production. So what happens here? This EDC is not well purified, so that uh, to give a good amount of good amount of product, and the coke production here increases. Now the reason for coke production is due to as I said, the reason for the coke production is, as I said, the impurities goes into the cracker, which is heavy boil impurities and low boil impurities. So we need to purify this EDC after the oxychlorination process enough, so that the coke production can be decreases. Now, what will be the advantage after the after doing this? The campaign life will increase by approximate of 100 days, so that shutdown can be extended. The campaign life is a period up to which a process works properly, and after that, the pressure in this reactor, or you can say column, gets accumulated, and that's why we have to take the shutdown for the cleaning purpose. Now let us go through the handling. So as it is a petroleum product, so we should always keep away from the heat and spark. Also keep away from the eye contact. Other precautions are, as it is a heavy gas than air, so it may accumulate in the atmosphere if it leaks. So these are the precautions, and the storage requirements are, as we are doing this reaction on as we are doing this reaction on cryogenic form. So we have to store this product and reactant at so low temperature, so that it may not leak. Uses about 99% of the global vinyl chloride capacity of the production for PVC, and other for it is also used for the refrigerant, oxidation inhibitor, also for the vinyl and saran for the monomer and comonomer for fiber. Now the present market value of VCM will be $19.43 billion in 2027. For EDC, it is 945 per ton. It is the cost of the EDC, and for the HCl, it will reach it up to $1,718.4 million in 2028. Now the largest manufacturer, according to a report of 2017, are Reliance Industries, DISTILLATION, vinyl chloride monomer. Another is it is the second plant of the with Reliance Industries. Then comes the Phenolics Industries Ratnagiri plant 1 and plant 2. Then comes the Chemplast Sanmar Methur vinyl chloride monomer. Conclusion: the VCM is a balanced process. It is a leading edge technology for PVC production where ethylene oxychlorination plays a key role in the process. Although CuCl2 is a catalyst, but furthermore study should be done over here for the better understanding of the reaction. Now, in-depth knowledge analysis of fundamental understanding of reaction mechanism, ethylene oxychlorination, chemistry, material, and active site, including the interaction of CuCl2 with support and promoter, has been conducted. These are the reference we have used for our project. Thank you.